All right. Hey, Randy. Nice to see you
How you doing,
again.
Emily? Hi, Caleb.
Hi, Randy. Nice to finally meet you. I'm a big
Yeah.
fan.
All right. Hey, let me go back to a couple of things you just said.
Yes.
One, on the wax dip. We've been wax dipping for over 50 years. And I just finished up a large project, which I have not published yet. I will soon, but I'll give you, let you know the results right now. We tested out with a good wax dip. We have boxes that have been out in the elements for 50 years, and we're still using them. Some of them we have re-dipped during the interim, but they just don't rot. Beeswax biodegrades too fast, so that's not a good wax to use. If beeswax did not biodegrade, you'd be up to your neck in beeswax right now, because there's been bees for millions of years. Okay, if the beeswax didn't biodegrade, it would be neck deep. Okay, so that tells you whether something's biodegradable. Okay, for example, the only reason that we're not over our heads in wood is because of termites.
Yeah.
Okay. So anyway, we tested a number of different waxes and wax mixtures, and the microcrystalline wax, which has a slightly different structure. The regular paraffin wax has carbon chains with hydrogens on the side, just straight carbon chains. Microcrystalline has branched chains, so has certain properties. But as far as we did a year-long trial in sun and rain, dipping a whole bunch of different blocks, and we found the double dip, where you dip them once for about a minute till the bubbling slows down, pull them out, let them cool a little bit, and then do a 1 second dip back in. That puts a heavier coat on, and those blocks after a year in the elements look like the first day we put them out there. There's no change whatsoever. It's really, really good. The only question with the copper, and we use the copper on our bottom cleats where they touch the ground, but we're hesitant to put the copper in where the bees actually will be touching it, to avoid any contamination into our honey. And I haven't seen data on whether there is contamination or not, but people ask us about that. So the dipping alone with the wax makes it unnecessary to put any kind of preservative on the rest of the hive bodies. Second, on the VarroxSan, when you said the only test isn't whether they survived, because you don't know why they died or not. The test is you take mite washes when you start, and take mite washes after 2 months and see what the difference is. We set a new record 2 days ago for a number of mites in a mite wash of a half cup of bees. There's about 315 bees in a half cup of bees. And we normally, in the springtime, as you said, when the mites are mostly in the brood, about 80% of the mites in the brood, that's swarming season. You have your maximum percentage of mites in the brood, about 80%. At that time, a mite wash of even one mite is cause for thinking about treating. Later in the summer, it drops to about 50% of the mites are in the brood. So we'll let it get up maybe to 5 or 6 mites and then do treating. Our record was 429 mites on 315 bees. And they had brood. That was a colony with brood.
Oh my gosh.
I opened it up. I took one look at a brood frame and go, oh no, my God, this is going to be terrible. I told Rose, who was doing the wash and counting them, I said, put on your seatbelt because this is going to hurt. And I took a picture of her looking at this cup with this pile of mites in the bottom. She had to divide it up into 4 cups just to get the count right on it. But that's by far the most record we've ever seen. Back to the VarroxSan, we just got some. It's not yet registered in California, but I have a pesticide research authorization, so I got some sent to me. We just put some on a number of colonies, but we're going a step further than just mite counts. We are titrating individual bees. We take out 10 bees at a time, drop each one into a test tube of an indicator solution, and then we have titration solutions we can drop in and tell you how many millionths of a gram of acid are on the outside of the bees' bodies. So we're comparing, and we'll do it with VarroxSan. We're going to do it at a week after application, 2 weeks, and 3 weeks after application. It usually peaks with the extended release formulations after about 4 to 7 days. You get your maximum amount on the bees, and then it starts to drop down from our previous research. We've done thousands of these titrations, okay? What it does is it saves you the time of going for 2 months and doing mite counts. You just look at how much acid is actually on the bees' bodies, week by week, and that's a really good idea of how well it distributes the acid. So one of the questions that we have found is that when you lay strips or sponges flat as opposed to hanging them vertical between the frames, common sense would tell you you'd get more exposure of acid on the bees' bodies if they were hung between the frames. And as with many things with beekeepers, common sense is completely wrong. So we find this over and over and over again. Whatever you convince yourself makes total perfect sense, no, just throw that out the window, because this is beekeeping, okay? And bee biology, okay? You need almost twice as much surface area on the hung strips as you do on flat strips to get the same amount. So the question was, if you were to lay some VarroxSan strips on flat across the top bars on a double deep between the brood chambers, how would that change the levels of oxalic acid on the bees' bodies? So 3 weeks from now, we'll be able to answer that question.
I look forward to that, because after going through 400 hives and dropping them in, it's like, oh,
God, yes.
Yeah, I know it'd be so much faster just to lay them down in between the colony.
Yeah, that's why we did the sponges. When we first started working with extended release oxalic, 6-7 years ago, and I remember we were at a yard, and we had made up the strips similar to the IUN cap from Argentina, and hung them in there, and tried them at different rates in hives. And I go, wow, this worked. And I called my son over. I said, hey, it really worked. Look at that is mite counts. He said, yeah. How many strips per hive? I said, well, there's 4 strips per hive body. He said, 8 strips per hive. I said, well, yeah, the 4 strips didn't do it. And he goes, Dad, 1,500 hives times 8 strips? No way. Come up with something better. So that's why I started experimenting with laying first the paper towels flat, and then to the sponges. What I found is when we lay the chipboard, similar to the VarroxSan, what it's made out of, that if you lay the same surface area as you would in the hung strips in a hive, you can overlay the hive. The bees beard up on the outside, and they all start vibrating their wings. They don't like it. So I'm running a trial right now, putting it in at the label rate, which is 1 strip for every 2.5 frames of bees, and then putting in other hive, equal number of hives, half that number or that full number laid flat across the top bars. So again, in a few weeks, I'll be able to look at the acid residues on the bees' bodies and see whether not only can you might be able to save yourself time, you might be able to cut the dose in half, which would be
amazing.
Because it's kind of
amazing.
It's kind of pricey to put in.
Yeah,
it is.
Yeah. And I just walked in just now from the lab mixing up solutions. Tomorrow we're going to test 4 different oxalic application methods in some singles that we have. We're going to do the dribble method, 5 milliliters per seam.
Yep.
We're going to use the spray method, where you actually pull each frame out. Obviously, too labor intensive for you or me, but the spray method. And I just finished calculating how much comes out of the sprayer, so I can put exactly the same dose on the bees and spray each side of each frame. And then we're going to do the an oxalic acid vaporization with the same dose of oxalic acid. And then we have a nebulizer that a friend is inventing. That puts a finer than a fog. You have the foggers, but then you have nebulizers. Nebulizers are a finer droplet than a fogger. And we're going to try the nebulizer from the top. Again, I'll put the same dose on. And then what we find is you get your maximum amount of oxalic on the bees' bodies about an hour after you have applied it. Even with the oxalic vaporization, if you titrate them immediately after the vaporization, the dose is not very high. But after they've walked over the combs for an hour, they pick up the acid off the combs, and that's when it maxes out on the bees' bodies. So we're going to apply those. An hour later, we'll check to see what maxes out, and then we'll do it at 8 hours, and then we'll do it, before we go to sleep that night, and then we'll do it again the next day after 24 hours, and we'll have the data on comparing the bee to bee, because you do 10 bees, and we can see how much variation there is from bee to bee. So I know with the dribble, you have some bees that'll have 0 micrograms on their bodies. Most will have something like 30 or 40 micrograms, and you get the occasional one that might have 120 micrograms on their body. So huge, because the dribble doesn't hit every bee. Some bees, they get a glob on their wings, and they have a lot of it. Other ones just miss it. So that's why the fogger or the vaporizer or the nebulizer will see how much more evenly it distributes it on the bees.
Okay, interesting. Definitely interested to hear that because before we send to California, I have dribbled them before. And last year I was about ready to buy this vaporizer, and I was like, well, do you do the dribble or do you vaporize? But of course, we have the cold going against us, so you have them clustered. But I've dribbled the last couple of years, but it'll be interesting to see your research on that.
I've done a lot of research, soon to be published also, on vaporizers. There is a best set point temperature. You cannot do a super fast vaporizer by raising the temperature high, as some manufacturers are doing, because that just fries the oxalic acid. So I've measured how much acid actually comes out of a vaporizer at different set point temperatures and different brands of vaporizers. So I'll be publishing all of that. The short answer is that if you get half out what you put in, if you do it really well, maybe 60%. But essentially, if you're putting it 2 grams in, you're going to get 1 gram out of the vaporizer. So and that doesn't mean anything wrong about it. It just means that if you're afraid that you're putting in a whole lot, you're actually only about half of what you're putting into the vaporizer goes into the hive. The other half is degraded into carbon monoxide and water. Carbon monoxide, carbon dioxide, and water. There's also if you go on the internet, of course, you're going to find out all kinds of erroneous information. And people say, oh yeah, well, it turns into formic acid. No, it doesn't turn into formic acid unless you take your set point temperature up sky high, and then you will get formic acid. But at the normal set point temperature, there's virtually, if any, formic acid produced.
Quick question.
I'm actually really... Oh, go ahead.
Real quick, what is the set temperature? Because on the ProVap from Man Lake, it was set to 230.
That's a good one.
Just got... Okay, yeah, because I just got it in today.
Okay, so 230, you get about 50% recovery. If you go up to 250 or 260, you get slightly higher recovery. But if you have a battery-powered one, the battery won't last as long.
Okay.
I feel like mine is set for even higher than that from the manufacturer. I swore it was like 400.
400,
that would explain.
You start getting major degradation of the acid.
Okay, because I was actually going to mention, it's cool that you're looking into this, because I've noticed now this is the second year that I've used oxalic acid during this time of year. Used it first thing in the morning when the temperatures are kind of cooled. Now, last year and this year, it did get up to like 90 degrees those days. And in Michigan, we have a lot of humidity, so it might have been a little hot. But oxalic acid's supposed to be, you can use it at any temperature as far as I'm aware.
Yeah, as far as I'm aware, too.
Okay. But what I noticed is that it almost looks as if I'm hitting them with a formic treatment in the symptoms that I see afterwards. The queen stops laying for a little bit. It's like they lose her scent, because I had some of them where the queen just disappeared. They didn't even make a queen cell from it.
Okay.
And then they burnt the brood too. And then there's also like a drop in the bee population as well.
That's interesting. That may be due to the humidity. See, where I'm testing in California, unfortunately, we don't have humidity out here. so
unfortunately, right.
so I can't do any high humidity testing now, because the acid in high humidity, the dry acid is harmless. If you have dry skin and you put oxalic acid crystals on your dry skin, you can hold them all day long, nothing will happen. If you sweat, it'll burn through your hand. So you need, until the acid molecule hydrolyzes, separates into the positively charged hydronium ion and the negatively charged oxalate ion, it has no action. It has to be dissolved in the water. And that's why we put the glycerin in the extended release. The glycerin only is a humectant. It absorbs moisture from the air and allows the acid to dissolve and become active. So if you are vaporizing in a high humidity environment, that's very interesting observation, because I don't notice that adverse effect in our hives when we do vaporization. So I'm thinking as I'm talking about how I could, make a high humidity chamber to test that out. Okay, I'll see. Okay, if I don't suffocate myself by putting a plastic bag over me in the beehive, I'll see if I can get a high humidity beehive and try that out.
Now, question, Randy. So this is a question that me and so many other commercial guys have over here. Two questions. So with formic acid, and I know we just kind of covered it, you don't have humidity. But formic acid, does that humidity affect it too? Because we usually put it on after blueberries, and we're writing those fine line of temps of what the package says you can't do. What is it, like, don't go above 85? But we're wondering with that humidity, if that's playing a factor in too, where it's causing adverse effects with it. And second question is, I've asked this, I think I asked on the commercial page and no one had an answer, but can you put VarroxSan and Formic in at the same time, have those two treatments, and what would be the adverse effect on the bees?
Well, actually, that 429 count got exactly that treatment 2 days ago. And I'm going to go out.
Combination?
Yeah, as soon as I'm done talking to you, I'm going to go out and look at that hive. So in an hour, I'll have the answer on that one. No, we do that routinely with the extended release oxalic acid on the sponges. If the mite count is high, we'll put a time out treatment or a formic treatment in at the same time. So you get a quick knockdown, and then you get the extended release. Now, for us, that works fine. Back to your previous question about the formic. I'm doing a lot of experimentation with formic acid in the lab and in the incubator right now, and it's really interesting. Evaporation rates. So if you put a beaker out with formic acid in the beaker, it barely evaporates at all. And I tried 90% formic acid, 80%, 60%, and then 30%. And just again, what makes common sense? What makes common sense is that the 90% will evaporate the quickest. Well, actually, the 30% and 90% evaporate at the same rate, and the other two evaporate much more slowly. And which surprised me, of course, because it doesn't make sense. But what I realized is the density of formic acid vapor is like 4 times as dense as water. No, 4 times dense. Okay, water vapor is less dense than dry air. Again, many people get that wrong. They think that moist air will be more dense than dry air. It's just the opposite. Moist air is water vapor is about half the density of air. So water vapor will always, if you put a bucket upside down and put humidistats at the top, the middle, the bottom, and you put a pan of water in there and walk away from it, it'll always be 90% humidity at the very top, maybe 50% at the bottom, and 75% in the middle, day after day. So because the water vapor evaporates up to the top because it's less dense than the air. With the formic, it's so much more dense than air and way more dense than water vapor. When you put it in a beaker, a glass beaker, you have this vertical that has to rise up in order to evaporate. And that's why the low formic acid, my explanation of why the 30% evaporated as fast as the 90%, because there was so much water, higher proportion of water in it, that the water was evaporating. So right now, I'm testing some experimental methods of applying formic acid, and I have my incubator set up. The queen cells are out of it, so now I can use it with formic acid. I have several large incubators, converted upright freezers that I have converted into incubators. So I can put my formic pads in there, run them at hive temperature and humidity, and then twice a day, morning and night, go out and weigh those pads and then plot out the evaporation rates of the formic acid. Because I already know the target perfect evaporation rate. None of the products in the market give that. I'm trying to come up with something better, and I think I may be getting really close, actually.
That'd be wonderful.
That would be awesome. That would be awesome.
I get goosebumps right now. Pretty excited. It's the last 2 weeks of research are going really well. And actually, I'm going to be out and measuring one of them in a hive. So I'm done talking again in that same yard. I'm going to drive over there and see how that's working. But I'm in the hive. I did it with other experiments in hive last year, and based upon what I found, I know what the target evaporation rate per day is. The problem with the Formic Pro and the Mite quick strips is your first day flash off is way too high, and your second day and third day are too low. So the previous product before Mite quick strips came out was the Mite 2 pad. I don't know, you may not have been beekeeping back then. It was it was a big blue plastic bag with 50 holes in it and 300 milliliters of formic acid in it.
Oh my
gosh. And you put it in a rim on top of the hive, and it worked really well. But some of us, myself included, complained about having to have the damn rim. And so David, the manufacturer, gave up on that and changed to the strips. Since then, we now have purchased rims for every single one of our hives. and we recycle the old Mite 2 pads. We recharge them with formic acid again and use them over and over again because they were a superior product. So this is an example of a good product going off the market and being replaced by the same manufacturer by what we consider to be an inferior product. It has more problems. We don't have the more problems than we had with the old one. So based upon, and again, I've been researching formic acid for years. I'm always experimenting. I'm always running experiments. So I had a brainstorm recently and tried something out, and I think I may have nailed it. So you will find out soon.
That's awesome. I don't want to take up too much of your time, so just one more question, and I'll let you get off because I know you have a lot of stuff you need to do. So Phil Hoffland asked for when you're dribbling, if you've studied any other different bases when doing an OA dribble.
Oh yeah, we don't use the sugar anymore. In fact, what I just walked in was mixing up some solution, Oxalic dribble, for tomorrow's experiments. We use a glycerin now. The bees don't like to eat glycerin. They don't like to taste, apparently don't like the taste of glycerin. So the problem is if you use a glycerin in the dribble, the bees are more prone to eat it. And then if it's nurse bees that clean it up, when they're feeding the brood, part of the jelly that they feed the larvae, they have the mandibular gland component, which is the fats, the hypopharyngeal gland component, and that's white, the mandibular gland component. The hypopharyngeal gland component is clearer. That's the protein component. And then they add from their crops some nectar. Well, if they have just licked up a bunch of oxalic acid with sugar in it, and they feed that to the larvae, they can then poison the larvae. So to avoid that, we start mixing it with the glycerin. And we found out with the glycerin, the bees don't like really being dribbled with we used a 40% solution at first. They don't like that. When I put them in cage trials, it's obvious they don't like that much glycerin in their bodies. So we now use a 5% solution of glycerin, so which is very low. So to mix up a liter of it, you put in 50 milliliters of glycerin and top it off to 1,000 milliliters. So a very low proportion. And when I've tested it with both titration and with mite kill, that works as well as the sugar solution. It goes on easier. The bees take it really well. It's cheaper to make, so that's what we use now. And if you go to, if you Google oxalic acid treatment table, it'll come right up at my website. And at the top, I have it, even though I can't say it's an approved method by EPA, but the formula to mix it for experimental purposes. Now, as far as the EPA is concerned, it's totally legal to experiment with oxalic acid in your hives, all you want. It's up to they have handed off to your state regulators. EPA has no restrictions on own use of off-the-shelf oxalic acid. It's only your state lead agency that makes that decision. So the EPA is fine with beekeepers using it. They passed it off.
I saw your most recent post on your website talking about that.
Yeah. Yeah. So we put this in a strange position. So in some states, I don't name any, the bee inspectors don't give a shit if you're using if you're using the oxalic acid. They don't want you using the amitraz, tactic or bobitraz. But they're just not worried at all about it. But it depends upon your local inspector, if you get inspected.
Mm-hmm. It's just so frustrating. It's like,
no kidding.
It's just another rant for another day.
Oh yeah. We can rant away all we want. I can probably toss and turn at night. But I give up on the frustration. Yeah.
You do too, Randy.
Yes.
Yeah.
All right. Well, thanks, Randy. I'll let you go.
Yes.
Thanks for hopping on in such short notice, by the way.
Oh yeah.
And thank you for doing the experiments that needed to be done for many years, and
Oh yeah.
As a commercial, not a commercial, but as a beekeeper, thank you, Randy. I mean, I appreciate it, and so many others do.
And that's what keeps me going. The applied research that the beekeepers need for their questions, that the research scientists, they want to get in general, they want a publishable paper that's going to make it into a peer-reviewed journal. This type of stuff I do does not have that interest, to the editors. So what I do is just like Phil's question right there, or your questions. I get in my email questions from beekeepers all over the world every day. And when I start seeing a question coming up, if I'm able to do it, I work to try to get an answer to that question for the benefit of the beekeepers. So I appreciate.
Yes, we appreciate it, Randy. I mean, me alone, I appreciate it. I mean, what you do for the industry is. You don't get enough credit.
Okay.
No, not at all.
I do in my email. So and that's what, and people send donations. Some send $2 donations. Some send $5,000 donations. I'll tell you right now, when commercial beekeepers are sending me $5,000 donations, I know that they're serious, because commercial beekeepers are tight with their money. I don't make any money at it. That pays for my assistance, pays for my materials, pays for my research. I have to have a side job.
Yeah.
They're
here.
Yeah. But
same.
Yeah. But the main thing is the donations from beekeepers are telling me, hey, my research is of value to them, and that's such a really easy way to see that. That they took the time, even if they're sending $5, they're saying, hey, this research was of value to me. So that's how and like when I get somebody sending $200 or $500 donation, I generally write them a letter and say, okay, tell me, where do you live? What level of beekeeper are you? And what are the questions you are interested in answers to? And then that's the feedback I get to direct my research.
There we go.
Yeah.
It's a cool place to be. I work my ass off, but I really enjoy it. Okay.
Well, thank you, Randy.
Working my ass off, I got to get back to it.
Well, thank you, Randy.
Thanks again, Randy.
You betcha. Bye-bye.